Hello students, this is the physicist and we are going to discuss a very interesting math problem today for a change. Now, this question was given to me as a doubt by one of my SIT math students. He's a brilliant student, no doubt, but he also made us the same silly mistake which I did when I got this question for the first time. Then I realized my mistake. Well, actually, it's a very silly mistake. Let's read the question. The question says you have two circles, one smaller, one larger. Smaller one is circle A, the larger one is circle B, right? So let's take the center of circle B as B itself, center of circle A is A itself. Now it says that the radius of, let's say RA is the radius of circle A and let's say RB is the radius of circle B. And it says radius of circle A is one third of radius of circle B. That means RA is one third of RB, right? Now, if I take RA as R, that means RB will be 3R. Yes, clear? Now, if you want to take a moment to read the question and answer on your own, please do that. Pause the video, answer the question, and come back to the video to check if your answer is correct. And if not, then what should be the correct answer? Let me proceed. Now, it says circle A rolls around, pay attention to this, around circle B, one trip back to its starting point. That means it rolls like this and comes back here once. How many times will circle A revolve in total? Revolve in total. Revolve means what? Revolve the total number of revolutions, right? So how do you find? Let me draw the figure once again to clarify. Imagine if I have the blue circle. Okay, let's suppose this is the blue circle, which is the bigger circle. And let me put a smaller circle here on top of it. Okay. Now let's understand what happens. Let's suppose this point is P, point of contact right now, starting at the starting. This is A and this is B. Now, in one complete rotation, let's suppose in one complete rotation, circle A has come here. If it's one complete rotation, then this point will be once again P. Right? There are infinitely many points on the circumference of circle A. But we are talking about just one specific point of contact, which was the initial point of contact. In one full rotation, right, point P would have come back this distance, right? And what is this distance? This distance is the same as the circumference of the circle. Let's call this distance d. So d is equal to 2 pi times r, which is the radius of the circle A, right? Now, imagine in such n number of intervals, point P will come back here. So the total distance d is the total distance spanned by the point P along circle B is, let's consider that D. That means the circumference of the larger circle, which is 2 pi times 3r, right? So when point P covers a total distance D, how many revolutions will it do? So it's the number of small d's that lie inside capital D. So the number of revolutions is capital D by small d, which is 2 pi 3r by 2 pi r, which is 3. And you think that's the answer? So you go back and you select 3 and bang, you are wrong. Why? You missed a very small thing. Very, very small thing. Understand, this is when you say n, it is not just n, it is n, right? N of what? N of the point P around B. Yes? Not around B, you can, yeah, you can say or rather you can say it's the n of what? The P moves around A, right? Let's call it around A. N of P around A. Yes or no? Let me explain what I mean, right? Imagine if I take this circle, right? Understand, if this point is P, right? This point is A. Understand, imagine if I spin the circle once, Understand? Imagine if I spin the circle once like this while keeping A fixed. Now you see, if A is fixed, P is moving around and this completes one circle, right? So how many such revolutions have happened? N, let's call it N of P relative to A. That is 3, yes. But what you're ignoring is that when you have the circle, right? When you have the circle, let me draw B here once again so that you understand. What you are ignoring here is, understand this circle, A itself is also revolving around the point B, yes or no? Gradually, right? As you can see, the circle itself is revolving, right? Okay, let's take this here and finally take this here, right? So A is also moving around B, yes or no? Yes. So, and that motion is what? One circle, complete, right? So this circle, small circle, has done one revolution in itself around B, right? So you forgot that. So n of A relative to B is 1. That means the total number of revolutions, capital N, will be n of P around A plus n of A around B. And that is 3 plus 1, which is 4. Understand, whatever is the value of NPA, you know how to do the calculation. It is 2 pi R, 2 pi RB over 2 pi RA. Simple. But total number of revolutions will be 2 pi RB over 2 pi. That is just RB over RA, yes or no? Right. So I can just write the total number of revolutions will always be in such a situation where a small circle revolves around a larger circle, or any circle, a small circle revolves around another circle while rolling over it. In that case, n is going to be how much? It's going to be RB over RA plus 1. That's the answer. Now, you would probably be thinking that it happens only because of the circle around which the outer circle moves, right? It doesn't have to be a circle, right? Let me just tell you that, let's suppose I have a straight line here, right? Straight line road. And let us suppose I place another circle over it, like this, right? Okay. Now understand. Imagine if when the circle rolls, when the circle rolls from point A to point B, right? If you can calculate, right? Understand. So the number of revolutions of, imagine the point of contact is P and A and B are just fixed to the road or the straight line. The point P is the point of contact at the bottom of the circle initially and it will be at the end. Understand here. Now understand N of P relative to what? Relative to the center O. Relative to, you can just call it N of number of revolutions, rather I will write it in blue, number of revolutions of P around A, let's suppose that is X. So understand, so basically while rolling over AB straight line, if it does X revolutions, then that is going to be N, the total number of revolutions. What if I allow the circle to just turn, like bend around without slipping, bend around like this, right? Bend around like this and then continue going rolling back, rolling on the bottom side of AB and then just turn around back to its original position. In that case, n will be x plus 1. Why? Because as you can see, right, as you can see, the rotation of A around the straight line, you can call the straight line to be, let's suppose, L. Around L is 1. Why? Because the circle has finished one revolution overall. Like as a circle, it has moved around, moved around one time once. But while rolling, it has moved. So it's not x. It's gonna be 2x, right? My mistake. It's not. It's gonna be 2x. Why? Because x here and then backwards also x, right? Forward x, backward x. So 2x plus 1. Remember, this also might be asked in SAT math or any other math exam, right? So that's it. I hope you've understood the mistake that you've done. I don't think you'll be disappointed with such a question. See you. Bye.